Hello, children. How are you all? And we were previously talking about the change in the state of matter. And when we heated the substances, they changed the state from solid to liquid and then to gas. And when we cool it, what happened was the reverse process happened. That is, gas changed to liquid and liquid to solid again. So, and we also have talked about the melting point and the boiling point, then the latent heat of fusion and the latent heat of vaporization. Now, here, children, today we are going to talk about change in the state, of course. Some more, a little more, we'll add to the change in the state, but also learn something about the factors affecting the change in the state. We already know that temperature or the heat is one of the factors which is causing the change in the state. But we'll also learn there is something more to it. There is one more thing which we will know that is causing or helping the state to change from one to another. Right here, children, I've already drawn the same diagram that I have drawn before. All right, so solid changing to liquid, liquid to gas, and this happens when we were heating. So solid changes to heat, liquid, liquid to gas. Solid is changing at a definite temperature when we are heating to liquid. So that definite temperature we call it as the melting point, and the liquid at a definite temperature or otherwise constant temperature, it is changing to gas. That is boiling point. Now, in case of water, right, solid ice. For ice to change into liquid water, the melting point is equal to 0 degrees Celsius. So that is the temperature we have seen. We got a constant horizontal line in the graph. And the next one, we have this liquid, that is water changing to steam. For water, the boiling point is 100 degree Celsius. So that's worth mentioning. So we talked about solid to liquid, liquid to gas in general, but specifically if it is water, so ice changes to water, liquid water at 0 degrees Celsius. So melting point of water is melting point of ice. We call it as melting point of ice is 0 degrees Celsius, and boiling point of water is 100 degree Celsius. And something more, children, for water to be specific, the latent heat of fusion is nearly 80 kilojoules per kg. If you have kg of ice, so it requires 80 kilojoules to change from solid ice to water. 1 kg of it takes that much of heat energy. And the next, if it is changing from liquid to gas, then the amount of heat required to change the state of liquid water to steam is nearly 2260 or 2256 kilojoules per kg. So children, don't you see a lot of difference here? So there's much energy required to change a liquid to gas than change solid to liquid. So what is the reason? What is the reason for so much of a difference? The reason is here there's a mere separation of the particles of the matter, but here it is giving energy to the particles of liquid so that they can get energy and fly away. So there's more energy in steam compared to that of the water. So if water is at 100 degrees Celsius, at the same temperature, you can also have steam because there's a change. There's a change temperature, or otherwise transition temperature, right? So if there is 100 degrees Celsius of water and 100 degrees Celsius of steam, what happens is that steam is not in the same state as that of water. So the temperature is same, the amount of heat in steam is more. That's why steam causes a lot of burns. So steam burns. So hot water, you may try to dip your hand in that, but steam is very difficult. It will burn and your skin feels soft due to that burn. So children, so that is latent heat of fusion and vaporization for water. Now I want to give you something else. Now children, can any solid change directly to gas? Is it possible? Yes. I'll give you an example, children. So we take some camphor. Camphor. You know what camphor is? Arti Karpur. Okay, so that camphor I take in a dish, and the next that I'll place it on a tripod stand like this, and place a cone over, and this is a watch glass or otherwise a small dish, a petri dish, some dish in which we have taken some camphor, and later on we have placed a funnel over it, and placed some cotton here, and heated from the bottom. Do you know what happens? Now, we usually actually expect any solid first to change to liquid and the liquid again change to gas. But that is not happening in this case. Do you know, the moment we heat the camphor without changing to liquid, it changes to vapor directly and goes and gas stick to the cotton. So if you just take out and smell that, you can smell camphor, and also you can see the shining crystals of camphor on this. So you can also use ammonium chloride instead of camphor, children, for this activity. So it is possible for a solid to change to gas directly, and that process we call it as sublimation. What is that called, children? Sublimation. What is that called? Sublimation. Now, okay, we have seen the process, that is onward process, solid to liquid, liquid to gas. That is, this is melting or fusion, and that is boiling or vaporization. That is sublimation. Okay, good. Now, when we start cooling it, what is the process called? Now, when gas is becoming liquid, so when steam, say, it becomes water. So what is that process called? That process is called as condensation. What is that called, children? Condensation. What is condensation? It's a reverse process. Now, what is the temperature at which gas becomes liquid? It is again for water is 100 degrees Celsius. So at the same boiling point temperature, the reverse process happens. So while heating, it is liquid to gas. While cooling, it is gas to liquid. But the transition temperature is same. But this, the sense is a little different, opposite. So we may call it as a condensation point. So that's boiling point, of course, but it's not that process, but the reverse process. So we call it as a condensation point. And the next, the liquid again changes to solid. Now, what is this change called? Now, that is right, and liquid is changing to gas. Now, liquid is changing to a solid. Now, what is this, children? So you can call it as solidification, or you call it as freezing. So this is called freezing. Freezing is nothing but the opposite process to fusion or melting. So children, right, that's the thing that we wanted to learn. So we'll continue learning, children, for a while. So children, right, we talked about the freezing, and then next there's a condensation, freezing, the reverse. And is it possible for any gas to directly convert to solid? Is it possible? Yes, it may be, but there is one term called as deposition, snow, frost, etc., from the atmosphere or in the air. When it's too cool, water drops will form ice. I mean, the vapor which is there in the atmosphere, there forms very small particles of ice. That's a frost, or you can say frost. That's frost. So frost, you can say, it is a process of conversion of a gas directly to solid. So this is deposition. What's that process, children? Deposition. Now, okay, right. So now we talk about factors affecting what, children? Change in the state of matter. One, children, what is the factor which is affecting the state of matter? First one, we have already seen heat, or heat. It is at a particular temperature, or it is temperature, you can say. But heat and temperature both are not same. Heating or cooling. So it is temperature, heating or cooling. Heating or cooling, and it is specifically the temperature which determines the change of state from solid to liquid, or liquid to gas, or gas to liquid, or liquid to solid state. Now, is there any other factor which is affecting the change in the state. Now, okay, children, right? I'll tell you one thing. If you have a block of ice or a piece of ice and try to press it hard, press any coin on that, and you try to press it hard, do you know what happens? You find that the place where the coin is there, when you are pressing, you find that starts melting. That starts melting. Now, okay, so what is happening, children, there? So, right, so we understand that pressure also plays an important role in change in the state of matter. Right, okay. So, press and melt. So, this is utilized by the ice skaters. When ice skaters, they wear the shoe with a very sharp knife-like edges on the soles. And when they skate, the body weight falling on that causes pressure on the ice that is there on the floor, and the ice melts, and these people glide over the ice or otherwise slide easily and perform all those acrobatics. Okay, so children, so pressure plays an important role in changing the state. So what is the pressure doing while changing the state? So imagine you are taking a syringe and you have some gas in it. As you compress it, what will happen during that? So the particles of the gas, they start coming closer and closer. As they are coming closer, the force of attraction become more, and the what do you call, children, that intermolecular space decreases. And if you are able to decrease the temperature at that place, so what happens? The particles there come so close that they can change to liquid, and you continue to press harder that liquid and reduce the temperature. What happens, children? The force of attraction becomes firm, and the particles, the interparticular space becomes small, and thereby the liquid changes to solid. So pressure also plays an important role in change of the state. Increase the pressure, and gas can change to liquid. Liquid can change to solid. Now, there's one more thing. If at all you decrease the pressure, so what can happen? Opposite will happen. If solid is there, if you start decreasing the what I call it, if you start decreasing the pressure, solid may change to liquid. Liquid changes to gas. That is possible. The next one, children, there is heat. And now, where is this thing utilized when pressure is exerted on any gas and that becomes a liquid or a solid? Is it used at any place? Yes, we have carbon dioxide. Carbon dioxide gas, when it is compressed and cooled suddenly, what happens is that carbon dioxide, it becomes ice. It is not ice due to water, but it is ice which is not wet. It is not wetting. So it is ice which is dry. So that dry ice is nothing but solid carbon dioxide. Solid carbon dioxide is also called as dry ice. What is that? Dry ice. So here we find solid carbon dioxide is converted to solid, right? Okay. Next one, children. Now, okay, in the case of your refrigerator, also there is a compressor which is working, and when the compressor fan works, it draws the coolant gas that is there and compresses it, and that becomes a liquid. And the moment it stops, that liquid again. It becomes in one way it becomes gas, and that spreads while it is spreading. What's happening is it's drying the heat from the things that are inside, and it helps in cooling that way. Right, now, children, now, is there any other way by which we can understand that change of state, or is there any other factor which can cause change in the state? Okay, right, I'll tell you something, children. I'll give you one idea. This is something out of your book, you can say, but it's worth learning. Now, so you eat a block of ice. Say you are taking a piece of ice and putting it in your mouth. Can you do it? It's impossible. Your tongue will become numb because it's so cold. The temperature is somewhere around -10 degrees Celsius, and it takes a lot of heat. It requires a lot of heat to melt. So that is not that cannot be supplied so immediately. But you eat an ice cream, don't you? You eat an ice cream, but the ice cream that you can eat, it melts the moment you put it in your mouth. On the tongue, it melts so quickly. What is the difference between these two? So the melting point of ice we know is 0 degrees Celsius. But do you know the temperature of ice cream? That ice cream will be somewhere around less than 10 degrees Celsius, minus 10 degrees Celsius. That is around minus 16 degrees Celsius. Now, what is the reason that it is melting? But actually, when you look at the ice cream people, the manufacturers, they add a little of salt to the ice, crushed ice. There'll be crushed ice. To that, they add a little of salt to that. This addition of salt will reduce its melting point. So the ice, when it touches, it is melting at a temperature of nearly minus 16 degree Celsius or a little more than that. So what happened to the melting point, children? Now here we have not added anything, but we have not pressurized or otherwise decreased the pressure, did anything. But at the same temperature is able to measure. It is able to melt. It's because of addition of salt. So some impurities, not impurities, but some other material, when added to a given substance, it can reduce the melting point or sometimes melting point of certain solids. And the example for that is now, okay, we have magnesium oxide is a substance, and that from that, when extracting magnesium chloride is a substance, and when extracting magnesium from that by the process of electrolysis, we add certain impurity like sodium chloride or potassium chloride to it. So the addition of that extra material to the substance, it helps us decrease the melting point of that original solid. So thus we understand, children, addition of certain impurities, addition of certain impurities, addition of certain impurities also can change the melting or boiling point of the substances. Right, children? There we are. We have seen what we have learned today. We have learned about different the changes of state. Again, the terms melting point, boiling point. We have revised. We have seen the values of melting point, boiling point for water, and also have seen the what I call this latent heat of fusion and values of latent heat of fusion and vaporization for water. Later, we have seen new terms. We have learned some new terms like the like what is called the condensation. The next one, freezing, and later on we have also learned sublimation, change of state from solid to gas directly, and deposition, another term where the change is from gaseous state directly to solid state. Okay, children, right now, so from solid to liquid is melting or fusion, liquid to gas, it is boiling or vaporization. From gaseous state to liquid state, it's condensation, and the next one, the change of state from liquid to solid state is freezing, and the last one, and the next solid directly changing to gas, that is called as sublimation, and gas directly changing to the solid, that's called deposition. And later on we have seen how pressure and pressure also affects the change in the state of substances, and children, and the addition of other some impurities also. Okay, right, children, and carbon dioxide, as I gave you an idea, solid carbon dioxide is called dry ice, but when pressure is decreased, do you know what happens, children? At 1 atmosphere pressure, it will directly change to gas without getting converted to liquid. So that is what we have learned, children, today. And following this, you will have a worksheet again, and that you take it, go through this video, go through the chapters, this part of the lesson from your textbook, read it well, and fill it, and bring it when you are returning to the school. Thank you very much.